now we are going to start Venn diagram. Okay. Now for this Venn diagram, see, we draw a circle for any kind of proposition, and for universal proposition we generally shade the circle or the portion of the proposition. And for particular proposition, universal means A and E, and particular means I and O. And for the particular proposition, we put a cross inside the circle. Okay. Now, if this is a proposition, suppose all men are mortal. So, for each term, we will use a symbol. For this man, this is suppose subject, and this is predicate. So, this circle is for subject, and this circle is for P. Okay. Now, see, this is the circle of S, and this is the circle of P. Okay. Now, outside the circle, we can write SP. Okay. Now, here you can see, if I write in all the portions of both the circles, these are two intersecting circles because this is a whole sentence. This is the intersecting circle for the whole sentence. All men are P. Now I have put both subject and predicate in all the sections of the circle. Now you see, in this section P is absent. In this section P is absent, so I will put a bar on the P. And in this section S is absent. You can see S is start from here, so S is absent in this portion, so I will put a bar on S. In this section both the circles are here, so I won't put any bar. And here no S, no P, because this is outside the circle, so I will put a bar on both, because there is no S, no P. In this section you can see only S is there, P is not there, so P bar. In this section S is not there, only P is there, so S bar. And in this section both the S and P are here intersecting in this place, so SP is here. Okay. So now you can see, if SP bar is there, it is equal to 0. Equal to means universal proposition. This is equal to 0 and this is not equal to 0. That means particular proposition. So you can see I and O are not equal to 0, and A and E are equal to 0. And in the Boolean scale of opposition, we have already read that A means SP bar equal to 0, E means SP equal to 0, I means SP not equal to 0, and O means SP bar not equal to 0. So if this is a proposition, so this is SP bar equal to 0. So this is SP bar. This section is SP bar. And for this equal to 0 or universal proposition, we put shade. So we will put shade here. Okay. But if this is a particular proposition, then in this SP section, we will put a cross. Okay. Suppose this is I proposition. Suppose this section is I proposition. Then not equal to 0. That means I will put a cross here. So now let us start with the argument. Suppose we have an argument which is E, A, E, 2. Means these are the propositions, these are the two premises, and this is the conclusion, and it is in second figure. Second figure means the middle term will be in the right side of both the premises. That we know. In the second figure, middle term is in the predicate of both the premises. And our conclusion we know is always SP. And in the conclusion, the subject of the conclusion is called the minor term, which will be there in the minor premise. And the predicate of the conclusion is the major term, which will be there in the major premise. So the EAE2 form stands like this. Okay. Now as this is, the first one is E proposition, so we will start with S. No. Okay. E proposition starts with no, and the first one is PM. No, P is M. Okay. Second one is A proposition, and A proposition starts with all. Second line is SM, so all S is M. Okay. And the third line is the conclusion, which is again E proposition, which starts with no, and there is SP. That means S is P. Okay. Now in the first one, that is E proposition, so E proposition there is PM, and E proposition, the symbolization stands like this: subject predicate equal to 0. So subject predicate equal to 0. Second one is A. So A proposition, there is SM. Okay. Now what is the symbolization of A proposition? Subject predicate bar equal to 0. That is subject predicate bar equal to 0. And the conclusion is E proposition, where there is SP, and E, what is the symbolization of SP? SP equal to 0. One is subject predicate equal to 0. So subject predicate, there will be no bar, equal to 0. Now we have to draw this in a Venn diagram. Now how many terms are there? S, P and M. So there will be 3 intersecting circles. 1, 2 and this is 3. Okay. This circle is for S, this circle is for P, and this circle is for M. Okay. Now in this portion you can see there is only S. In this portion there is only S. So I will write SPM in everywhere and will find out in which portion which one is absent. The absent one will be termed as bar. So as there are 3 propositions, I will put SPM in all the sections. Okay, you can see in all the section I have put SPM, and now I will find out which one is absent where. So here you can see in this portion only S is present and others are absent. So I will put bar on others. In this section only M is present, others are absent. So I will put bar on others. In this section only P is present. So I will put bar on others. And in these 4 sections, in these sections you see M is there, P is there, S is there, but P is not there. You can see M is there, you can see M is there, S is there, but P is not there. Okay, so I will write P bar. In this section P and M is there, but S is not there. So I will put a S here. I will put a bar on S. In this section all the 3 are here, so I won't put any bar. And this section S is there and P is there. You can see M is not there, so I will put a bar on the M, only on M. Okay. Now I have to find out. First of all, you remember this, we won't draw the conclusion. The conclusion will automatically drawn after drawing the 2 premises. The conclusion will be automatically drawn after drawing the 2 premises, and we have to see in the 2 premises, if here you can see both are universal propositions, but if there is one universal and one particular, then we have to draw the universal one first. If there is, again I am telling, if there is one universal and one particular, then we have to draw the universal one first. But here you can see both the premises are universal. So I can start with anyone. So I will start with first one, PM. Where is PM? You have to find PM. Only PM. No bar. Okay. So here is only PM. Here is only PM. In other cases, either there is bar on M, either there is bar on P, but I need only PM. You can see I need only PM. So PM is only here and here, and as it is equal to 0, So I will shade it. As it is equal to 0, so I will shade it, okay, on the sections of PM. Now coming on to the, you can see I have given shade on the PM section only. Second one is S amber equal to 0. That is again shading, but I have to find out the places where there is S amber. Forget about P now. S amber. You can see there is S amber and there is S amber. There is no bar on S, but there is bar on M. In other cases there is bar on S. But in these two cases, I can see, forget about P now, S amber, and as it is equal to 0, I have to shade it again. Okay, so I have shaded. Okay, now my drawing of both the premises are done. Now I have to see whether the conclusion is automatically drawn or not. What is the conclusion? Conclusion is SP. And equal to 0 means it should be shaded. So where is SP? There is no bar on S and no bar on P. Forget about M here because there is no M. SP. You can see in these two cases there is no bar on SP. In other cases there is bar on S or there is bar on P. But in these two cases only there is no bar on SP and both the cases are shaded. And there is no bar on SP and equal to 0 means that should be shaded, and we can see I have not shaded. It is automatically shaded after drawing the two propositions. As the conclusion is automatically shaded, that means this argument is valid. But if it is that both the premises are already drawn but the conclusion is not automatically drawn, then that means this argument is invalid. Let me take another one to show how an argument can be invalid. So I have taken one argument as EAO3. Okay, now EAO3 means this is third figure. And third figure seems to be like this. The middle term is subject in both the premises and the conclusion is SP. S is the minor term, so it will be in the minor premise, and P is the major term, it will be in the major premise. Okay, now this is the first premise, so I will write E. E starts with no. E starts with no, and in first one there is MP. So no M is P. Okay. Second one is A. So it will start with all, and second line is MS. So all M is S. And third line is SP. That is the conclusion is O. So O starts with sum and it is a negative one. Sum S is not P. Okay. Now I will symbolize. Now first one is E and there is MP. In first one there is MP and we know what is the symbolization of E. Subject predicate equal to 0. So I will write subject predicate equal to 0. Second one is A. There is MS. Now what is the symbolization of A proposition? Subject predicate bar equal to 0. So subject predicate bar equal to 0. And the third one is O proposition where there is only SP. So what is the symbolization of O proposition? Subject predicate bar not equal to 0. Subject predicate bar not equal to 0. Okay, now the symbolization is complete. Now I will draw, as there are three terms, I will draw three circles, intersecting circles for this diagram. Okay, this is the circle of S, this is the circle of P, and this is the circle of M. And I will put SPM in every section first of all, and then I will find out which one is absent in which circle, and the absent one will be termed as bar. Okay. Now in this section you can see only S is there, so I will put bar on others. In this section only P is there, so I will put bar on S and M. In this section only M is there, so I will put bar on SP. Okay. Now in this section you can see S and M are there, P is not there, so I will put P bar. In this section you can see S is not there, P and M is there, so I will put bar on S. In this section all the three are there, so I won't put any bar. And in this section you can see S and P are there, but M is not there, so I will put a bar on M. Okay. Now I have to draw and find out whether the conclusion is automatically drawn or not. Now again I have to see both the premises, whether there is any particular or universal. If there is one particular and one universal, then I have to draw the universal one first. But here in this argument we can see both the premises are universal, so I can start with any one. So first one is MP. So I will forget about S now. I will just find out MP. Where is MP? See, there is MP. Okay. And there is MP, and where there is no bar. You can see in the first line there is no bar. MP and MP, and it is equal to 0. That means it should be, both the section will be shaded. And remember, we will find two sections for each of the proposition as the terms are used twice. Now second one is M as bar. We won't draw the conclusion, it will be automatically drawn. If it is automatically drawn, it is valid. If it is not automatically drawn, then it is invalid. Now second one is A proposition, M S bar. We will find the places now. M S bar, okay, and M S bar again here. So equal to 0 means it will be shaded. So I will shade first this section, M S bar. You can see M S bar, M S bar. This portion is once shaded, but again for this second sentence, as the shading is again there, so I will again shade it, and I will write here double shaded, as I have shaded doubly for first proposition and for second proposition again. Okay. Now the conclusion is SP bar. SP bar section is this one and this one. And there is not equal to 0, and we know for not equal to 0 we put an X. But here I cannot put, because we know that the conclusion should be automatically drawn. But here it is not drawn. It should be crossed there, but it is not drawn from the premises. As it is not drawn from the premises automatically, that means this one is invalid. And how this is invalid, you can test it through the syllogism. You can see this is E proposition, both the terms are distributed. This is A proposition, subject is distributed and predicate is not distributed. This is O proposition, subject is not distributed and predicate is distributed. Okay, predicate is distributed. Now subject is not distributed and predicate is distributed. So what will be the reason for this invalidity? Can you tell me that? Middle term is distributed in both the cases. Major term is distributed here, and it is also distributed in the major premise. Minor term is not distributed, so we don't have to see the premises. So what is the reason behind the invalidity of this syllogism? That if the conclusion is particular, that means actually one of the premise must be particular. But here we can see the premise is not particular. So in this way we can draw the Venn diagrams to find out the validity or invalidity of the arguments.